There's a secret sitting at the bottom of the sea. It's been down there for so long, it's turned into a fossil. And it holds clues to a mystery that's almost as old as life itself. Is there some kind of connection between Earth and the moon? This question has bounced around in humans' noggins for thousands of years. Early cultures wove lunar myths into their folklore. Astrology became intertwined with everyday life. And over in China, they even built some temples on the moon. But it wasn't until the 20th century that we got our first hard evidence about the moon's origin. We discovered that it was chock full of stuff like aluminum and silicon. And because we knew Earth had loads of that stuff, we started to think the moon was some kind of space shrapnel. A wayward chunk of Earth blasted out of orbit and then smacked into a passing asteroid. Bam! Moon! Pretty intuitive. But here's the thing. Scientists now know that's not the whole story. The moon's composition isn't quite Earth enough. It's missing some key components and some trace elements that are super common here. So something's been hiding from us. Something that will reveal the moon's true story. Something that's sitting at the bottom of the ocean right now. Right now, as we speak. A team of scientists is hunting for that something off the coast of China. They're dropping a big orange net into the water, hauling up moon rocks and sifting through them carefully. These rocks come from the bottom of the seafloor, which is covered in sediment layers. Each layer like a page in a book, recording what happened on Earth over the past 65 million years. And they think the moon's secrets are hidden in here. In microscopic fossils of phytoplankton that lived millions of years ago. And if they can extract and analyze these fossils, they might be able to figure out how the moon got here. It all comes down to a theory proposed in 2008. Back then, two researchers wondered if the moon was born from a different kind of collision, not between Earth and an asteroid, but between Earth and another young planet about twice the size of Mars. They named it Dea. This little protoplanet would have been bellying around the Earth, eventually crashing into it in a cataclysmic collision. Most of it would have gotten incorporated into Earth, but some chunks would have flown away and eventually cooled down, hardening into the moon. So if this impact is real, it would have left a mark. There should be evidence of Dea inside our planet. And if it crashed into Earth 4.5 billion years ago, we should find rocks from that era deep in our seafloor. Unfortunately, Earth's recycling system, Akara plate tectonics, tends to erase this kind of evidence. Most of the ancient crust has been gobbled up by the mantle or flung out into the ocean where it has been eroded to nothing. The only remaining pieces are here in these sediments. That's why scientists are poring over them now. If they can find microfossils in the right layers, it could prove once and for all that the moon was born from a collision between Earth and a wayward planet. It would be a classic example of scientific detective work. And you don't need a fancy telescope to pull off this kind of investigation. Sometimes you just need a bucket and a shovel. Now let's take a step back and celebrate the power of scientific thinking. We've all heard tall tales about the moon. Maybe you were told that humans once walked on the moon. You can hear it in the lyrics of songs. You can even see it in Hollywood movies. Our fascination with the moon has been constant throughout human history, but we didn't always have the tools to make sense of what we saw. Without telescopes, the moon looked like an unanswerable mystery. And that's totally understandable. How do you go from this to this? But over time, as we learned more about astronomy and physics, we started to challenge these traditional stories. For example, we used to think the Earth was flat. But we've known for centuries that this isn't the case. Then there's Aristotle's idea that heavy objects fall faster than lighter ones. That was a prevailing theory for 2,000 years until Galileo came along. Using the scientific method, he challenged these beliefs, setting the stage for modern physics. And today, we're continuing that tradition. We're taking existing stories and checking them against the facts, which brings us back to the moon. What's the origin story you grew up with? Was the moon a gift from an alien race? Did it sprout naturally from Earth? Did a bunch of ducks pile up on its surface? Okay, maybe that last one wasn't part of your childhood, but people actually believed it for hundreds of years. Either way, we're taking these ideas and putting them to the test. Not because we want to debunk them, but because we want to understand the world better. Science is about embracing curiosity, asking questions, testing theories. It's a journey, not a destination. So the next time you see the moon, remember, it's not just a pretty face. It's a window into the history of our solar system, a silent witness to the dramatic events that shaped our world. And who knows what new discoveries await us. Maybe someday soon we'll be able to tell the complete story of the moon, and maybe it'll turn out that the old tailies were right. After all, in the realm of science, anything is possible. As Carl Sagan said, science is a way of thinking much more than it is a body of knowledge. It's a way of discovery. It's a way of dealing with the unknown. So whether the moon is a detached chunk of Earth or a remnant of a shattered planet, one thing is clear. It's part of our story. Understanding its origins helps us piece together our own history and shows us just how dynamic our planet and solar system really are. When we look up at the night sky, we often marvel at the twinkling lights scattered across the expanse of darkness. We might see a constellation or spot a shooting star without realizing that each point of light tells a unique story. One such celestial body has puzzled astronomers for decades. Fast radio bursts, also known as FRBs, are intense pulses of radiation that originate billions of light years away. They appear as brief, bright blips in the radio spectrum, lasting only milliseconds before fading into the cosmic abyss. Since their discovery in 2001, FRBs have captured the imagination of scientists and space enthusiasts alike. Their sudden appearance, immense energy, and short duration make them enigmatic phenomena, challenging our understanding of the universe. Over the past 2 decades, astronomers have managed to detect around 2,000 each, leaving them with more questions than answers. These celestial fireworks pose various mysteries that have yet to be unraveled. Where do they come from? What causes them to flare up? And why do they appear so sporadically? The search for answers has led to some extraordinary theories and observations, pushing the boundaries of our knowledge about the cosmos. One notable discovery was made in 2020 when astronomers detected an FRB repeating for the first time. This breakthrough provided a much-needed clue to the enigma of these bursts. By studying this repeating FRB, scientists hope to unlock the secrets behind their behavior, shedding light on the nature of these elusive cosmic events. In the vast expanse of space, where wonders abound and mysteries deepen, the quest to understand fast radio bursts stands as a testament to humanity's insatiable curiosity. With each new discovery, we come one step closer to unraveling the secrets of the universe. If you've been enjoying this journey through the cosmos with me, I invite you to join our community. Click the link below to subscribe to our channel. Together, we can continue to explore the wonders of the universe and uncover the secrets that lie within. Don't forget to leave a comment below to share your thoughts and join the conversation. Your support means the world to me and keeps me motivated to bring you more fascinating stories about the universe. As we delve deeper into the mysteries of space, I hope you'll continue to be a part of this incredible community. Let's keep exploring, keep questioning, and keep discovering. Thank you for watching. See you next time.